Of Inside's closest and most trusted partners, and I'm sure a partner for many of you here today. Please give a warm welcome to the Director of Product Management, Greater China for AMD, Ms. Irene Hwang.
Thank you very much. Thank you very much, everyone. My name is Irene Hwang. I'm the Director of Product Management in AMD's Client and Graphics Product Division. Sorry about that. You and I communicate better visually. This is something that shouldn't be a surprise to most of us, but arguably AMD was one of the first in the industry to recognize this. Looking ahead as to what matters today and in the near future, HD visual experience, multiple content sources, etc. Delivering the best visual experience, knowing that we all communicate better visually, is at the center of everything AMD does, and it's going to be very central to everything I'm going to discuss with you today. Sorry about that. Moving along. In the not too distant future, the user interfaces are going to have a lot more natural interaction to them. As is shown here, what you'll see coming out of a lot of the universities is some of the interfaces that we're showing here and in some of the products that are shipping already. Web browsers. The next generation of web browsers are going to be very suitable for your grandparents because of the high element of touch and ease of use. As is already happening today, the average user is capturing their own data. User-generated data really exploded with the introduction of video and typical or enhanced HD cameras being put into things like smartphones and such. But what's happening more and more is that these average users are manipulating their content. Entertainment is actually fun, but these days it's not actually fun unless you're a part of it, and we're going to see more and more of this immersive entertainment going to continue in the future. Of course, advanced communications will continue to progress. And then finally, the workplace. My peers earlier today talked a lot about the business and the enterprise environment. Today and tomorrow's knowledge worker is going to be expected to be far more productive given the amount of computing resources available to them, saving their precious time for real problem solving. So in short, AMD, we design products and solutions for experience-based computing, knowing that we all communicate better visually. It's not just about us. A lot of my peers are here today. We want to make sure our devices work and talk to one another, talk over the cloud, in an open standards ecosystem. I'm going to talk about a few major areas today, starting with our graphics products, moving on to our Fusion APUs, and then about our software strategy. And we're going to bring that all together and make sure everything works together. Getting right into our target markets. Shown here are actually AMD's target markets. Several of these markets are growing and are extremely large. But we're not just in the market of delivering semiconductor hardware. I'm going to tie everything together for you, knowing that we all communicate better visually. To some of us, this is a known fact, but I have to take this opportunity to reiterate. There's only 2 companies in the world who develop world-class x86 processors in volume. And then on the right-hand side, there's only 2 companies in the world, you can guess who continue to innovate and deliver leading-edge 3D graphics technology. AMD is the only company that actually does both. What does this mean? This means that we can, as needed, balance between the 2 sides depending on the workload that the users are demanding. Our strategy on the product side has 3 pillars. The first pillar is to develop winning platforms. What is a winning platform? A platform involves the hardware, CPU, APU, GPU, the chipset perhaps, also the software, the power management, shifting between all of the components, and obviously making sure any component that is actually in the system that the user is paying for is being used. And we have a concept called dual graphics that I'll describe later on. In the middle, GPU technology. This will be my next section. The Radeon brand has been our flagship brand for world-leading graphics technology for years. But we want to differentiate with graphics. We want to not only offer PC users an upsell to their notebook or desktop by adding graphics, but we want to leverage that IP into what we call on the right a Fusion Accelerated Processing Unit, or APU. So these are related. Again, our product strategy has three main pillars. I'll talk about each of them. In short, by differentiating with GPU technology, the Fusion processor itself is highly capable because it has a very parallel engine. Over time, we're going to need to make sure that the software developers can actually assign instructions to both the GPU engine internally and the CPU traditionally. And this is what AMD is calling heterogeneous computing. By definition, the word in English, heterogeneous, means not the same. So the GPU, highly parallel, is not the same type of core as a CPU, which typically handles serial tasks. So the idea of heterogeneous computing has only begun with the physical integration of the two products. And we believe the way we've implemented it is well suited for the user experiences of the near future. So I talked a lot so far about our high level, what users are going to be doing. Now I'm going to give you a brief video and then delve into the GPU Radeon technology. Wow. So the video describes it far better than I can, but I'm going to try. So AMD's been on the leading edge of graphics technology for several years. So looking back, what the video tried to highlight was we started really the first era, which was well before this century. And we call that the fixed function era, where the hardware is actually graphics specific and the programmers tended to be very specialized in programming GPUs. Moving ahead, between 2002 to 2006, AMD introduced floating point processing, which actually introduced limited shaders and obviously enhanced the image quality of the graphics itself. And then the third era has really started where the graphics is starting to act and help things beyond gaming. And we introduced a unified shader architecture just after 2007. And then within the third era, which is continuing today, there's a concept called GPU compute. In short, GPU compute means the graphics processor can be used for gaming, as traditionally, and more. So keep this concept in mind as we talk not just about Radeon, but as I introduce the Fusion APU. So the idea of GPU compute is only beginning right now. Our GPU strategy from a product and go-to-market perspective has 4 pillars. The first one is to execute and hit key industry inflection points. These inflection points might be interface-related, memory-related, or bus-related. So for example, AMD was the first to move from AGP to PCI Express. We were the first to put DDR3 and GDDR5 into memory into our graphics cards. And the list continues and continues. Secondly, the most immersive experience. So like I said at the very beginning, I'm going to keep talking about how the user experience is driving everything we do. We want to make sure we deliver every user, whether it's the gamer or the workstation content creator or the average person editing their HD video, the most immersive experience. The third pillar is performance leadership. We never sacrifice performance leadership, and we continue to offer the world's fastest graphics solutions, as I'll show you shortly. And then finally, it's not just about the hardware, it's about the software. We've always reached out to the software community to make sure that they get early look at our hardware so they can start developing their software to take advantage of what we're introducing in our hardware. This is just a timeline of some of the features I talked about to make sure that we stay on the leading edge of graphics technology and some of the industry inflection points I had mentioned earlier, PCI Express, DDR3, G5. We were also the first to demonstrate 28 nanometer GPU technology a month ago here in Taiwan. So like some of my peers mentioned, a lot of stuff is happening here in Taiwan. And AMD hosted our Fusion Technical Forum a month ago and demonstrated 28 nanometer GPU technology, which tends to be on slightly different nodes than our CPU peers. DX11, this happens to be a Microsoft standard, but we are 2/3 of the market of the GPUs shipped in the world. So this is phenomenal in terms of leadership. And what has mattered to the user that when you have an inflection point and you hit time to market, this is when, frankly, a lot of the initial excitement and bulk buying and shifting from the old generation, DX10 over to DX11 starts happening. So we're extremely proud of this stat. AMD also introduced these unique features. Eyefinity allows a user to drive 3 to 6 monitors from a single GPU. But we're not just stretching the screen. You can actually see more. So you can hit enemies in games that your competitor who only has one screen could not see. We call this single large surface. Additionally, within Eyefinity, there's several different modes that can be enabled for extremely low cost, leveraging DisplayPort 1.2, very low cost adapters and hubs. So we're extremely proud of this technology, and our competitor does not actually offer it. So we continue to try to innovate in ways that benefits a more immersive user experience. We also support top to bottom stereo 3D and encourage an open ecosystem. Dual graphics. This is part of essentially our platform strategy. In short, when you have 2 graphics systems in your computer, you want them both to be working, and this is what dual graphics is. So you see tremendously additive performance when a Radeon graphics card or chip is used in conjunction with an AMD APU. And then I talked about performance. The 6990 desktop and mobile graphics processors are the world's fastest, and we're extremely proud of this. And we're not just packing more die size into previous generation technology. We're putting some smarts into the chip. We're making sure that, for example, we can take advantage of the TDP that we've allocated and drive up those frequencies on certain games. Whereas if you're running a benchmark, for example, in 3D Mark, that's a worst case, but it's also an artificial environment. that sets our clocks. So we're doing a lot of innovative things to make sure that we pull ahead of the competition and continue to innovate in GPU technology. We're working with world-class partners both on the gaming side as well as on the multimedia and the non-gaming front to make sure that these software partners have an early look at our hardware and that they can continue their development. So in summary, the Radeon product line innovates on all four of these factors, and we're extremely proud of our product line. And looking ahead, we continue to lead. As I mentioned a month ago, we were the first to demonstrate 28 nanometer GPU technology at our own forum, and we continue to make sure to offer performance and world-class graphics. Now, our Radeon product line is intended as, for the most part, an upsell. So if you buy a system and you want to do more advanced graphics, video, and multimedia, you can obviously upsell either your notebook or your desktop to include a Radeon graphics. However, if you recall, our strategy is all leadership. Continue the leadership, but leverage it into more mainstream or more widely installed systems. So where are we taking you next? APU is an accelerated processing unit. I will describe it in more detail next. But Radeon graphics is definitely a part of the overall solution of the future. So I threw out a few points here, such as virtual memory. Over time, we're going to enable software programmers who've historically only programmed for x86 to access and to assign instructions to the GPU. And when I mean to the GPU, I mean to the GPU within the APU or to the external GPU, such as a Radeon. Additionally, dual graphics and cell-up graphics, of course, enables user experience to be even better. Now I'm going to talk about our client products. I'll just skip over this because we already showed it earlier. This is basically a summary chart of my first few slides, but I wanted to draw out two examples that I did not touch on that are extremely innovative but not too far in the future. The first one is, sorry about that. The first one is natural UI and gestures. The Xbox 360 has an additional component, the Connect, which is gesture-based. And in case you guys are not aware, AMD's graphics is actually inside the Xbox 360. So the Connect gesture is actually done or processed primarily on the GPU. So this idea is already happening today, and more with natural UI and gesture and touch. The processing is done faster, more power efficiently in a parallel processing environment or GPU. Augmented reality is another trend. So I'm sure some of you have heard of Avatar. So augmented reality is if I'm having a video chat with someone, I want them to see me talking, but I don't want them to see me. So I'm going to superimpose another person or avatar of me who moves and who speaks when I speak. This is, for whatever reason, a very interesting trend that's already taken a lot of popularity. All of this type of usage and computing is done more effectively when there's a very powerful graphics engine. So I'm going to talk a little bit about history and then what brought us to develop an APU and then where we're going with it. A few years ago, on the left-hand side, just as an example, I'm showing an Athlon 2, and on the right-hand side, I'm showing a 9800, Radeon 9800 Pro, which is a GPU. So a few years ago, programmers did a few things. They programmed for the lowest common denominator. So they would write programs for what's largely integrated graphics because the install base was much larger. Secondly, the graphics programming was quite complicated and arguably remains a little bit more complicated than higher level object-oriented programming. Most of the workload a few years ago of a computer was actually done by the serial x86 processor. Fast forward a few years to last year. As an example, the multi-core CPU I'll put here is a Phenom. And on the right-hand side, I'm going to put the 5870, which is our generation from last year. Look at the sheer number of transistors. 2.15 billion transistors. Teraflops class GPU was introduced. Now, on the application side, just a year ago, was really an explosion of HD user-generated content. What do I mean by that? DSLRs were cheaper and much more widely available. So users would actually generate their own content. Secondly, HD gaming was really mainstream by this time frame. At the same time, on the CPU side, multi-core is a very innovative concept, and we continue to put many cores inside our CPU. However, at some point, scalability and power becomes a limiting factor. And the paradox that we're really trying to solve is a computing industry paradox. How can people in the computing industry continue to offer year-on-year performance improvement? Well, one way is, of course, manufacturing. Year-on-year performance improvement, given that the applications continue to improve year-on-year, but form factors are shrinking. This is the paradox that drove us to develop a product that we're calling the APU. So we call this the big experience, small form factor paradox. And it's still ongoing, but I would say that we've come up with a few near-term solutions, and we're going to continue to evolve those in the years to come. So the first solution to this paradox we're calling the E-Series. The E-Series launched about a year ago, and it's phenomenally successful accelerated processing unit. So it actually combines a discrete class DX11 GPU. Again, we have world-class GPU technology, a CPU, and the North Bridge into a very small footprint, suitable for all-in-one notebooks up to 14, even 15 inches. We're seeing customers using the E-Series. And of course, netbooks and even tablets. We have some Win 7 tablets shipping with the E-Series APU. But we didn't stop here. Again, I said it launched almost a year ago. We stepped it up a level because we care about experience. So we launched the A-Series. The A-Series obviously has a slightly bigger footprint, but packs in even more performance into a smaller footprint. Now remember, the paradox we've been trying to solve is the customers expect year-on-year performance gains. The applications and the usage experiences are growing every year, and form factors are shrinking. So what you're going to see in the near future from us is options. As the form factors evolve, whether they become very thin or remain sort of like your traditional notebooks, we will continue to make sure we have solutions that give great performance but fit into the power envelopes of these form factors. So the introduction of the advent of the APU, which we started shipping a year ago, is really the biggest shift in processor technology since x86 was invented 30 years ago, and we're extremely proud of this. Now, die integration of a GPU with a CPU is something we came up with a while ago, and others are trying to do. But it's how you do it, and what percentage of your design actually is that GPU, and what is the capability of the GPU that you put inside. The layer above that is being able to program tasks that run better in parallel environments onto the GPU when it makes sense, or to shift it over to the x86 side of the chip when it makes sense, and to power shift between the two so you're not trading off battery life. Now, the world recognized this innovation, and here in Taipei, again, I keep referring to Taipei, back in June, we were awarded the Best Choice of Computex Taipei Award for this innovation, and we're extremely proud of it, and we're going to keep taking it to the next level. We also try to measure ourselves to the best of our abilities across a number of metrics, whether it's video quality, gaming, battery life, or compute. battery life continues to be important, but I want to touch on the idea that you don't want to trade off performance for battery life. So even when you add an additional Radeon graphics into your notebook, for example, we offer a 0-watt mode where you can actually use the discrete graphics when plugged in, but turn it off when you're on battery mode. So the user doesn't have to make a choice between buying a high-performing system versus buying something that has great battery life. And I mentioned this dual graphics earlier on. I'm going to mention it again. In this exact example, we're putting an A8 with our 6670 graphics card, and you see phenomenal additive scaling. These are some of the reviews. I mean, more so than ever, AMD has made significant inroads in the mobile notebook space. We don't want to forget about performance. We do continue to innovate on the x86 side because, first of all, there's a wide set of applications that continue to be programming and accessing the x86 space. In addition, there are some types of scenarios that are best suited still for serial processing. So we have two main cores, Bulldozer, which is now shipping, and Bobcat, and they, as shown here, have vastly different objectives. Now let's get into another video.
With us, we have among the most respected overclockers in the AMD community. What we're trying to do is see what we can do with AMD FX. And the question is just how far can we go?
So we're not running any benchmarks, we're just shooting for the highest CPU-Z. So we boot up from the BIOS with pretty safe, easy settings, and then we'll adjust the frequencies on the fly. Just seeing how the frequency scales, going from air, water, phase to extreme. So we're just going up little by little, 7 gigahertz so far, no problem.
These days, we've kind of stepped it up a bit. When we run liquid nitrogen, it's kind of a preliminary test for us, and it's been overclocking for the rest of the world for a long time.
7873, getting closer to the 8 gigahertz. 8 gigahertz. When we switch over to helium, the base temperature has usually been between negative 220 and 230. 8.335 megahertz. That was the highest CPU frequency ever. And we had the virus scanner enabled. Let's see if we can go higher. So this would be 8420 if we can make it. 8429.
Congratulations, everyone. That is awesome.
I don't suggest you try that at home, but we're extremely proud to have broken a world record recently for the frequency achieved by a CPU. So performance does matter to us, as it has traditionally and certainly for some segments of the market. So the FX processor, which is based on the Bulldozer core, was a first and only CPU to reach 8.4 gigahertz. Okay. Finally, I want to bring it together and make sure that the software applications and developers are able to take advantage of the unique way we put together the hardware components. DX11, I mentioned it earlier, but it's worth seeing the difference. So in this particular game, you can see the tiles much more clearly than in DX10. So it's not just a check mark on the product you're trying to sell. It actually makes a difference. All of the developers were given DX11 hardware from AMD because we were ahead of our esteemed GPU competitor by a significant mile. And they continue to develop for DX11 going forward. We have yet to see the China market, for instance, really adopt this. But again, we want to make sure the hardware and the early stage software development really proceeds mainstream. And this particular transition slide just highlights that everyday use in terms of the Microsoft suite of applications is accelerated when you have a GPU or a better GPU in your APU or a discrete one in your system. We continue to partner with key multimedia software developers shown here, and we've also invested in some. We've invested in some companies that are specifically are able to take advantage of the APU's architecture in cleaning up video or cleaning up video or motion. And then I did want to mention our partner Microsoft. We are going to be ready for Windows 8. More importantly, the development community with the OpenCL and C++ AMP and such have a much easier way of writing applications that can take advantage of the GPU within the APU. We have a commitment to open standards. I mentioned this at the beginning. It's not just about us. It's about our hardware working with software and working with each other and making sure that the open standards are leveraged. Over time, it's been proven time and time again that open standards will persist and will typically win. So in summary, I just wanted to recap some of the highlights I talked about. First of all, the industry leadership. We're extremely proud to have really changed and disrupted the way that we architect a processor to make sure that it's ready for the next generation of software developers and users. We also have over 2/3 of the market when it comes to DX11. We shipped, well, this number's a little old, but we shipped well over 12 million APUs already, and we just launched the A series actually back in June. We have over 300 design wins, so better time than ever to get out there and find our products on the shelf. Everything has been launched and is now shipping. One slide on the future. Next year, we're actually launching an APU called the Trinity. It's a code name. And it's actually going to incorporate the bulldozer, which you saw in that video, into an APU form factor. And performance continues to matter to us, both on the graphics side as well as on the platform side. So in summary, visual experience is extremely important to us. We continue to have groundbreaking firsts on innovation on features like Eyefinity on the GPU side, which we're then going to leverage into the platform side for a wider install base. We continue to work both with our manufacturing as well as on our design smarts, both software and in hardware, to make sure that we can deliver better and better performance as the form factors get smaller. And they will get smaller. And open standards, we believe, always win. Thank you very much.